Now we shall talk about only lines which are passing through, pair of lines which are passing through the origin. That means you should visualize the pair of lines in this manner. One line passing through the origin, another line passing through the origin. This is L1, this is L2. We have noticed that, suppose I write this equation, L1's equation, it will be y equal to m1x. So m1x minus y equal to 0 will be one line. Similarly, L2 will be m2x minus y equal to 0. When I find the combined equation, m1x minus y into m2x minus y equal to 0, and when we expand this equation, the coefficients will be m1 m2 x square minus m1 plus m2 xy plus y square equal to 0. So from this, what we have noticed is, whenever the lines are passing through the origin, their combined equation will have only three terms: x square term, xy term, y square term. And if you look at the degree, the index is 2 here. The combined equation of xy, 1 plus 1, that is also 2. Combined power of y is also 2. So we call such an equation as a homogeneous equation of second degree. When do you use your homogeneous equation is whenever the degrees are all equal. Every term has got the same degree, we call it homogeneous. Every term is having degree 2, so we call it as homogeneous equation of second degree. And general equation, how does that means we need to write the general equation of two lines passing through the origin. The general equation of two lines passing through the origin will be of the form ax square plus 2hxy plus by square equal to 0. It is like this. If a single line's equation, we know it is a linear equation. Same way, every homogeneous equation represents combined equation of two lines which are passing through the origin. This is the most important thing to remember in this. Combined equation of any two lines passing through the origin is always a homogeneous equation of second degree. This lecture, we are going to find out if a combined equation is given to you, how will you separate the equation? I'll give you an example. Suppose I have an equation x square minus 5xy plus 6y square equal to 0. I want to find out the separate equation represented by this equation. We know that this represents two lines passing the origin. What is their separate equation? You have noticed that the difference is 5 and product should be 6. So we can solve like a quadratic equation. X square minus 3xy minus 2xy plus 6y square equal to 0. Minus 3 into minus 2 gives you plus 6. Taking x common, so x minus 3y minus 2y common, x minus 3y equal to 0. So if I take x minus 3y common, so x minus 3y into x minus 2y equal to 0. So it is of the form uv equal to 0. So the separate equations are x minus 3y equal to 0 and x minus 2y equal to 0 are the separate equations of these two lines. So you can imagine one of the line to be x minus 2y, this to be x minus 2y equal to 0. This line L2 is x minus 3y equal to 0. Now we will find out how we can separate this equation. Here the factorization is not possible. So when the factorization is not possible, how will we find out the separate equation? We can use 2-3 methods to do this. One simple method is make this equation quadratic in y. So how will you do it? Y square term first plus 4x into y plus x square equal to 0. Like it is like this: ay square plus by plus c equal to 0. This is the format of a quadratic equation y. If I am finding out the value of y, I will be using the formula minus b plus or minus root b square minus 4ac upon 2a. Now I will replace b by 4x, a by 1 and c by x square. So y is equal to minus 4x plus or minus root of, now 4x when I square it, 16x square minus 4 into a is 1 into c is x square, 1 into x square. upon 2 times a. A is 1, so 2 times 2. So y is equal to minus 4x plus or minus 16x square minus 4x square gives you root 12x square upon 2. So now I can get y is equal to, now let me take root of x square is x, so minus 4 plus or minus root 12 divided by 2 into x. Now if you want we can further simplify this, but my point here is I can separate the equation. One with a plus sign I'll get a one line, with a minus sign I'll get another line. Root 12 can be written as 2 root 3, so the equation can be written as y is equal to minus 4 plus or minus 2 root 3 upon upon 2 into x. That is y is equal to minus 2 plus or minus root 3 into x. So please note this. This is nothing but the slope of the line. So the slope of the line is minus 2 plus root 3 and minus 2 minus root 3. So we get two separate equations as y minus 2 plus root 3x and y equal to minus 2 minus root 3x are the separate equations of this line. This is one of the method, and we have a theory. In the theory, if we use this method, it will be much easier for us to prove the theorem that every homogeneous equation of second degree will always represent two lines passing through the origin. That's what we are going to prove the next theorem. We are going to prove that every homogeneous equation of second degree in x and y represents two lines passing through the origin. So what I have done is, like the previous problem, I have made this in quadratic in y, that is y square term, by square, 2hxy, this is a coefficient of y, and this is taken as a constant term. That means a quadratic equation ay square plus by plus c equal to 0. A is b is 2hx, and c is ay. Substituting in the formula of solution of quadratic equation, we will get in place of b minus 2hx, b 4x square, that is square of b, 2hx, and 4ac. Now you can see the x square is common, and x square is within the root. So when you take 4 is common, so I have taken 4 common, x square a minus ab, and x square common, but the root is removed. That's why degree is x is 1. Then we have 2hx here also. So we have 2hx. So x is common between the both. Root of 4 is 2. So that is also taken common. So we get the separate equations are y is equal to minus h plus or minus root x square minus ab upon b into x. So we can notice one important thing here. We said that this equation represents a pair of lines, but one condition is there. If the root of negative number occurs, then this would become imaginary. So if x square minus ab happen to be negative, this pair of lines would become imaginary lines. If x square minus ab is positive, then you will get two distinct pair of lines. And if x square minus ab becomes 0, you will get two coincident lines. That means both the lines will be one over the other. That means if you can visualize in the graph only one line, we call it as coincident line. So here is a condition. If x square minus ab is 0, we get lines are coincident. If x square minus ab is greater than 0, lines are distinct. And there will be two lines will be distinct. And if x square minus ab is less than 0, then the lines would be imaginary. So if they ask you, what is the condition for lines to be real? Both these two together, that is x square minus ab is greater than or equal to 0, the lines will be real. You will be able to visualize the line. When x square minus ab equal to 0, you will be able to visualize only one line when we plot the graph of this type of equation. So this is a very important point to note. So whenever we ask you, what does this equation represent? We need to say that this equation represents a pair of lines passing through the origin. If x square minus ab is 0, the lines will be coincident. X square minus ab is greater than 0, the lines will be real and distinct. And if x square minus ab is less than 0, the lines will be imaginary. The lines will be imaginary.